molecular formula, empirical formula, and how to derive what is the relation between the two. Okay, now let us consider the molecular formula first. You know, the formula that tells us the actual number of atoms present in one molecule of a substance is called the molecular formula. Let's take one example, glucose. Okay, the formula of glucose is C6H12O6. Okay, that means one molecule of glucose contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So this is the actual number of atoms present in various elements in one molecule. The elements are carbon, hydrogen, oxygen, and you are giving the actual number of atoms. Oxygen contains 6 atoms, hydrogen 12, carbon 6. So this is the molecular formula. Now comes the empirical formula, which says that it is the formula that expresses the simplest ratio of the atoms, okay, of the various elements. Okay, so if you take the ratio of these atoms in the simplest form, okay, that is the empirical formula. So the same compound glucose is having the empirical formula CH2O. Okay, how come? 6 1s are 6, 6 2s are 12, 6 1s are 6. That's what the ratio, 1:2:1. So this is the empirical formula of the same compound glucose, right? Now let us discuss the relation between the two. Relation, okay, between molecular formula and the empirical formula. Okay, we can consider like this: the ratio of molecular formula by empirical formula is same as the ratio of molecular weight, okay, by empirical weight, and this gives you a number raised to nearest whole number, that is n. Okay, a nearest whole number. Clear? Now if you find the ratio, okay, it will come the same whether it is the ratio of molecular formula to empirical formula or molecular weight to empirical weight. Let's take the same example. The molecular formula of glucose can be written as CH2O multiplied by 6. Okay, that's come to C6H12O6, right? The empirical formula is CH2O. So if you cut it in the lowest term, it comes to 6, which is same as, now what is the molecular weight of glucose? Carbon 12 6, okay, that is 72 plus 12 into 1, that is 12, plus 16 6 96, divided by the empirical weight 12, that is for carbon, 2 atoms of hydrogen, that is 2 into 1 2, plus 1 atom of oxygen 16. So this comes to 180 by 30. Again it is coming 6. Here also you are getting 6. This is the value n. Okay, so if you want to find the relation between molecular formula and empirical formula, now this will be the application. Molecular formula equals to empirical formula into n, right? By cross multiplication, molecular formula, empirical formula equals to n. So this is the relation, right? So when you are going to apply this formula, there will be numericals concerning with how to find the molecular formula after empirical formula. Okay, now we can calculate this value of n by using this formula. N equals to molecular weight by empirical weight. This is the application when you are doing numericals. Okay. Now here we are going to apply these in solving numericals. Okay. Let us take one example. Now there is a question. Hydrocarbon. Hydrocarbon means a compound containing hydrogen and carbon. It's a binary compound. A hydrocarbon contains 80% of carbon and rest hydrogen. Okay. Find the empirical formula and also the molecular formula if molecular weight is 30. Okay, that means the whole calculation for empirical and molecular formula is involved in this. Okay, so first find the empirical formula. Okay, now the steps for empirical formula. First, the first column will comprise of elements. Okay, we have carbon and hydrogen. Okay, use symbols because you are finding the empirical formula. The next step is percentage composition. Okay, you know the percentage of carbon is 80, so write 80%. Rest hydrogen means the hydrogen percent will be 20%. Okay, now here we are going to write the atomic ratio. For this you have to divide the percentage by the atomic weight of the element. Since the atomic weight of element carbon is 12, so 80 by 12. Let it be 6.66. Okay. Now divide the percentage of 100 by its atomic weight. This comes to 20. Right. Now the fourth column will comprise of simple ratio. Okay. The simple ratio over here means divide the result in the third column by the smallest number. The smallest number is 6.66. Okay, so divide this by 6.66 both. Here you get 1. Here 20 by 6.66. Okay, now pay attention over here. This is 6.66, which is the result of this. So can we replace this number by this? That is 20 divided by, this is the division sign, 80 by 12. So it comes to 20 into 12 by 80, which comes to 3. So the simplest ratio is 1 and 3. 1 for carbon, hydrogen has 3. So this is the simplest ratio of the elements. So the empirical formula is CH3. Okay. Now after this we are going to find out the molecular formula. Now pay attention. This is the column for molecular formula. Okay. For molecular formula, you have to begin from empirical formula. Look at the steps. Step 1. First write the weight of this particular empirical formula. The empirical weight is to be found first. Empirical weight is carbon 12 plus hydrogen 3, so it is coming 12 plus 3, which is 15. This is step 1. Okay. Now comes the step 2. In step 2 we are going to mention the molecular weight. Okay, the molecular weight is given 30, so you write 30 over here. Sometimes this may not be given. Okay, you will give vapor density. If vapor density is given, pay attention, then the molecular weight is 2 times the vapor density. So either vapor density will be provided or molecular weight. Now comes the step 3. Please get the value of n. That means it is the ratio of molecular weight by empirical weight. So the molecular weight is 30, the empirical weight is 15, so it comes to 2. After getting the value of n, apply the last step, that is step 4. Okay, that means the molecular formula equals to empirical formula multiplied by n. Okay, so in this way the molecular formula for the compound comes CH3 multiplied by 2, that's the value of n, so it comes to C2H6. Okay, so this is the molecular formula. So the 4 steps of molecular formula: get the empirical weight first, knowing from the empirical formula, then molecular weight. If molecular weight is not given, vapor density is given, multiply vapor density by 2 to get the molecular weight. Then step 3 is molecular weight by empirical weight, the value of n is coming, which is nearest whole number 2. Then the last step is molecular formula equals to empirical formula into n. So this is the ultimate. So remember the 4 columns for empirical formula and 4 steps for molecular formula. Now sometimes you might be given like this. Suppose the empirical formula of a compound is given A2B3. Okay. Now A and B are not elements. Okay. It is simply the symbols. Now this particular empirical formula is given, and it is given that empirical weight equals to the vapor density of the compound. Okay, and you have to find the molecular formula. So the molecular formula is to be found. We are following the 4 steps for this question also. The first step is that we are going to find the empirical weight. This is, let us say, x. Now comes the second step, that is molecular weight. You know that molecular weight is twice the vapor density. Since the empirical weight is same as vapor density, so vapor density is also x. So multiply by vapor density 2, that comes to 2x. Okay. Now third step, get the value of n using this formula, molecular weight by empirical weight. So it is coming 2x by x, that is 2. Now the fourth step is molecular formula equals to empirical formula, that is, this is the empirical formula, A2B3 multiplied by 2. So the answer is A4B6. I hope this is clear. Okay. So thanks for watching. Hello students. We are going to discuss about the calculations based on chemical equations, in which sometimes the reactants are not 100% pure. Okay, that is what we are going to discuss, percentage purity of the reactant. Suppose we take the case of limestone. Limestone is having the formula CaCO3, that is calcium carbonate. This limestone is 80% pure and the sample is weighing 5 kg. Okay, the question says how much amount of quicklime means calcium oxide, how much amount of quicklime is obtained by heating 5 kg of limestone of 80% purity. Okay, so first and foremost thing is that the limestone is not 100% pure. and the formula of limestone is calcium carbonate. You are heating this and the products are quicklime, that is calcium oxide plus carbon dioxide. This is a gas, this is a solid product. Now if you write the mass parameters, calcium the weight is 40, carbonate is 12, 16 3 is 48, so it is 100 grams. So if you take 100 grams of pure sample calcium carbonate, that is 100% pure, it will give you 40 plus 16, 56 grams of calcium oxide and 44 grams of carbon dioxide, okay, by mass. Now the question is, how much amount of quicklime is there? 5 kg, okay, which is 80% pure. Now get the weight of pure limestone. 80% of 5 kg, that comes to 80 by 100 into 5, and that comes to 4 kg. That means 4000 grams, right? Now we shall take this as the basic statement. 100 gram of pure calcium carbonate gives 44 grams, sorry, this will be 56 grams because you have to find the weight of quicklime. 100 grams of pure calcium carbonate on heating gives 56 grams of pure limestone, quicklime, that is calcium oxide. So 1 gram will give you how much? 56 by 100. So what about 4000 grams? Because the sample is 80% pure. So 80% of 4 kg comes to 4 kg, that is 5 kg's 80% comes to 4000 grams. So 4000 gram will weigh how much? 56 by 100 into 4000. So in this way you have to work out. So it's coming 0, 4, 6, 24, 2, 4, 5, 22. So this is the sample weight of quicklime. That is 2.24 kg of quicklime. Okay. Now in the same question, if the volume of CO2 is asked, then we will proceed like this. 100 grams of limestone gives 22.4 liters of carbon dioxide at STP. So 4000 grams will give how much? In this way you can proceed solving questions. So this was the question based on percentage purity. That means the sample is not 100% pure. Okay. Thanks for watching.